I'm Eduardo and this is the JavaScript Haunted House. In order to interact with web pages, JavaScript uses a very important interface, the DOM. That's our topic in this chapter. Okay, but what is the DOM? The W3C DOM standard can be divided into three parts. Core DOM, which is a standard model for all types of documents. The XML DOM, standard model for XML documents. And the HTML DOM, which is a standard model for HTML documents. We're going to cover the HTML DOM in this chapter. To keep it simple, we can say that the HTML DOM is a standard which defines how we can access and change elements inside the HTML. This standard defines HTML elements as objects, the properties of all HTML elements, the methods to access all HTML elements, and the events for all HTML elements. Based on the code received from the server every time the page is loaded, the browser creates the page DOM. The HTML DOM is built as a tree of objects. With access to this tree, JavaScript has the power to manipulate the HTML dynamically. With the representation of our HTML as a tree, it is easy to understand how JavaScript navigates through this tree to change, add, and remove elements. The DOM is built after the window loads, so the document is accessed as a window object. We can access the DOM by window.document or simply document. They are the same thing. In the first chapter, we saw a DOM method that helps us to find specific tags in our document by the ID property. GetElementById is actually a DOM method. Methods are actions you can perform inside an HTML document. Besides GetElementById, we can select elements with GetElementsByTagName and GetElementsByClassName. Here we have a simple HTML we're going to use as an example to see how the selectors work. With a GetElementById, we can select a single element that has the matching ID, in this case the first div. Using GetElementsByTagName, we can select all the elements that are equal to some tag. In this case, all the paragraphs on the page. To get elements by class name, we provide a class name and the method returns all the elements with that class. In this case, the class left. We can also select some specific objects within the page directly by their names. Typing document element, we are selecting the whole HTML element of the page. Head returns the head. And surprise, surprise, body returns the body. We can also select more specific elements such as the page title, all forms, or even all pictures, as you can see. Now that we have figured out how to select HTML documents, let's see how we can modify them. The DOM has four main methods to change elements within the page, which are inner HTML, attribute, set attribute, and style.property. We have been using inner HTML in the previous chapters, so we know what it does. Let's store the P element with the spirit ID in the variable spirit. Using inner HTML, we can modify the element, changing its content. Stay calm. It's not behind you. Yet. With attribute method, we can modify HTML attributes of the elements, such as ID, title, and classes, among others. Using element.id, we can modify it, replacing the old ID with a new one. Powerful, isn't it? The attribute method can modify existing attributes. and the setAttribute method can set new attributes in an element. Let's set a class for our element called moving. When we update the page, we can see that our paragraph has now the class moving, and it's ready to move around the house. I'm joking, it's not going anywhere. I hope so. With style, we have access to the style properties of our elements. We can change any style property, such as text color. Starting by our element, we access the style, and among its properties we choose the color. We assign red to it, and if we update the page, we can see that our element has received an attribute style and it is now red. We can also edit an existing property in the same way. Now we know how to use the methods to find the elements, as well as change the values of their properties. Let's move on and see how we can add and remove elements in our HTML tree. For this, let's see a few methods provided by the DOM. Create element creates a new element. Remove child removes an element. Append child, which appends an element in an existing one. And replace child, which replaces an element. Let's see in practice how to add and remove HTML elements with JavaScript. This is the structure of our HTML. We're going to create a new element with JavaScript and add it to the HTML. We'll use the createElement method to create a new element. If we execute this code, it will create a new element and store it in the new element variable. Note that the element is not connected to our tree, so it won't appear in the browser. To do so, we need another statement that allows us to specify where we want to put the element we just created. That's when we need the appendChild method. AppendChild appends an element to another. The first step is to select the parent element. We will use the getElementById to select the div tag with the ID container. Now we just need to tell JavaScript what to do. Now the new element is connected to the DOM. To finish, let's write something inside the P so we can see it in the browser. To do so, let's use our old friend inner.html. Done. Let's see the result in the browser. When adding or removing DOM elements, we must always follow this order: parent, child. First, select the parent element, then we create, replace, or remove the children. Let's see another example. With this code, we are creating and putting a new element within the parent element. If we create a second element and append it to the parent element in the same way, it will be placed below the existing children, and the third below the second, and so on. If we don't want this order, good news, we have a way out. The InsertBefore method allows us to attach a new element above an existing one. Let's create a new paragraph and store it in a variable newp3. So we can use the InsertBefore method and see how it works. Always starting with the parent element, we call the InsertBefore, and in the first argument we pass the new element, while in the second argument we pass the reference element. Does it sound complicated? It's not. Let's run the code to see what it does. Done. Several ghosts added, in the order we defined it. Inventory time. We need more space, what do you think? Only one slot is not enough. Let's manipulate the DOM to create more slots in our inventory. Let's modify our addItem function. So instead of rewriting the first slot again and again, it creates another slot, put the item received in it, and add it to the inventory. The first step is to remove the old statement. We won't need it. To insert new elements, we need to follow a few steps. 1. Select parent element. 2. Create the new element. 3. Insert the item inside the new element. And 4. Attach new element to the parent element. So let's get our hands dirty. Let's create a variable UL and select the parent element by its ID. Below, we create a variable li and assign to the new li element. Using the inner HTML, we will put the received item inside it. Finally, we will attach the new li on the parent UL. Let's invoke the method we just created and pass as parameter the item we want to add. Look! A new slot has been created in our inventory with a new item. I don't know about you, but for me that's amazing. We already used parents and children, but we didn't take a look at a whole spooky family yet. Let's do this now. DOM elements have different types of relationships between them that can be of 3 different types: parent, child, and siblings. Let's take this code as an example to analyze the relationships. Here's the DOM with all its ramifications. The HTML element is the root element and therefore does not have parent. It is the parent of the head and body elements. Head and body are siblings. Head has a child, title, and the body has 2 children, 2 divs. The first div has also 2 children, a P element and an UL element. Finally, the UL is the parent of the 2 LIs. Each element has access to its parent, its children, and its siblings. A grandparent relationship, for example, does not exist for the DOM. To access the grandparent of an element, first select its parent and then its parent. From these 3 relationships, we can reach any element within the DOM, making navigation between elements a very useful trick to know. To learn how to navigate between the elements, let's use this code. First of all, let's find the div by its ID. Each element has properties that represent other elements related to it, and that's what allows us to navigate between them. We use our variable div to access the property children. It returns all children of the parent element in an array. We're going to learn how arrays work later on, but for now we just need to know that the array is similar to a list. You can access every item on that list by its index, like this. Let's move now to a more complex statement. With a console.log, we use our variable div to access its first child, which is a paragraph, and access its content. Let's run. There. We went down 2 levels to reach this result. We'll store the paragraph in a variable and access the contents of its next brother through the next element sibling property. We can also do the opposite with the property previous element sibling. We finished another chapter, and now you have knowledge to go further and do even more amazing things. Good luck in the challenge!